In this video, we will see the UART initialization in LPC2148 microcontroller. In the first step, you have to set the value of your peripheral clock using the APB divider register. In the second step, you have to configure the GPIO pins for UART transmission and reception. Then configure the direction of receiver pin as input and transmitter pin as output. After that, reset the FIFO and enable it. Then set the length of data bits along with the stop bit and parity bit as required. After that, generate the desired baud rate by computing the equation of baud rate generation. And finally, enable the UART0 transmission. Now let's come to the programming part of initialization of UART. So this is our function that we have made to initialize the UART, and inside this function we are passing the parameter of baud rate. So the required value of the baud rate can be passed from over here. So in the first step, we are defining an unsigned integer by the name of countVal. So what this integer will do is it will store the value of DLL and DLM registers. We will talk about this in upcoming steps. In the next step, we are setting the first bit of APB register as 1. So what this bit does is it sets the peripheral clock the same as the system clock. So if our system clock is 12 megahertz, then our peripheral clock will automatically be set to 12 megahertz. Then the next two steps after that, in that we are configuring the pin 0 and pin 1 of port 0 as transmitter and receiver pin of UART0. Then again in the next two steps, we are configuring the direction of receiver of UART as input and the transmitter as output. Then in the next step, we are resetting and enabling the FIFO from the FIFO control register. Then in the next step, in the line control register, we are setting the number of data bits we want in our packet as 8. We are setting our parity as 0 and we are setting our stop bit as 1. Then after that, we are calculating the value of DLM and DLL. As we are passing the value of baud rate, so that value will be passed over here, and the FOSC is basically our peripheral clock here. So in this equation, we are finding the value of DLL and DLM. Then in the next step, we are enabling the divisor latch for setting the fractional divisor value in the line control register. Now in the next two steps, the value that was stored in the countVal integer is stored in the DLL and DLM registers. Now all the above steps were valid until our required baud rate was less than 112500. But as soon as our requirement gets higher, then the value of DLL and DLM registers will change. And so for that, the settings will also change. So we have made an exception over here that if our baud rate is between 115200 and 460800, then these two steps will also execute. If our baud rate is less than 115200, then these steps are not needed, they can be skipped. So if we skip these steps, then our baud rate is set now, so we have to disable the divisor latch. So we can disable the next step, disables the divisor latch from here. And finally, we are enabling the transmission enable register of UART0 in order to transmit the data.